Hello and welcome back, guys. So since we are doing this practice questions of C programming, right? So let's get into it. So we were somewhere here, right? So factorial of a number. That's what we need to find. Okay, we need to get the input for the number. Of course, that will be scanf. It's a int percentage d comma and then will be and number. Right. Okay, inside the loop, multiply factorial with this. Okay, we need a loop for something, right? I equals to 1 till, not comma, but semicolon. I is less than equals to number. And of course, we will need to increase the I inside it, right? What do we need to do? We need to multiply loop multiply factorial with I. Okay, factorial multiply equals to I, right? That's what we need to do. Print f, and then we need to print out the factorial. Factorial. Right. So what we are doing? We are simply getting a number from the user, and then we already have a factorial variable, and we create a loop. Right. It means it'll start from 1 all the way to 1 when it is less than the number, and then we simply do a plus plus on it, and this means factorial equals to factorial times I, right? So I'm just writing it in shortcut form. Okay, so what we do now, we simply check the code. What happened? Okay, undeclared variable, because we need to declare it, right? Int, the data type was not declared by me. Okay, what happened? Okay, there is a semicolon missing. Let's fix that. Hopefully it works. Yep, it does work. Great. All right, let's submit. Okay, add numbers until user presses 0, right? So we will need a while loop for that. Right, so while loop that only breaks if the input is 0. Okay, while, yes, true, true, right, or while 1, right? So that also means like it's always running. Right, we will get scanf. We will need to get input value, that will be the number, I guess. Right, which is always true. Inside the loop, we need to get an integer input value from the user. And how do we do that? We use scanf percentage d and then the memory address of the number. Right, then we check if number equals, right? So we will need this thing, parentheses, number equals to 0. What do? We do break, right? So we terminate the loop. Right, outside there we need to do another thing as well. We need to print the sum as well, right? So that's what we want to find out. Will be sum. There's still a logic that I need to write, right? Otherwise, what do we do? Otherwise, we simply add the input value to the sum variable. Okay, not a big deal. Sum plus equals to the number. Right, let's check the code. Should perhaps run, I guess. I didn't make any mistake. Okay, works great. Yahoo! Right, so that's a simple problem. Let's check if it is a prime number or not. Right, we need to run a loop from 2 to number minus 1. Okay, so for int I equals to 2, and we will need to do okay. Okay, we will need to check the flag as well. Right, to do that, what we need to do is I equals number minus 1, right? And then we can simply do I plus plus, right? That's the logic. And inside the flag, of course, we will need the printf, printf, right? And inside there, we will put something, right? And we also need else. Why did I do flag? Because flag 1 means it's true, right? So that's why I do that. I paste it and check if the flag is 1. We need to print not a prime number. Otherwise, we need to print it's a prime number, right? Okay, that is done. Now what? We need to check if number divisible by I equals 0, not equals to 0. I not equals to 0. That means we will need to set the flag equals to not this thing, right? We will need to use this curly braces. My Python mind, of course, it works differently, right? So we need to do something like this. Control V, flag equals to 1. And that's it, right? Otherwise, we don't set the flag. That's it, right? So if we can divide it by that, in the first loop, it will be 2, and then it will come over here, whatever the number is, right? And then mm, until it's equal to, it'll run, right? Check code. Hopefully, I did not make a mistake. Okay, that's a prime number. That's fine. 21, it's not a prime number. My output was prime number. Everything was a prime number for us. Why is that? 21, 21, 21, 21. Why is that a 21? 21 was what? Divided by 3. Run a loop and check if the number is divisible by any number between that. 21 is divided by 3 sevens, right? 17 is, I'm just not sure about 21. 7 is a prime number. Mm, 21, and then when it reaches 7, right? So, of course, it's the 21, there will be a remainder, right? 21. 7, right? It's a prime number. Okay, that thing is always running. This condition is never being hit. Maybe the loop itself is not running now. Let's do that. It's not a prime number. Okay, 21. Am I making any logical mistake? I'm pretty. Let me just zoom out a little bit. Let me just see the output. So it's a prime number, prime number, prime number. That means either we are always hitting this, right? So that means it's never being checked. Right. So let's just do one thing. Let's do debug, right? Print f or something like that. Print f for modular thing, and then we simply do number like that. Right, let's just check the code. What's happening? Seems like it's not running, huh? The loop itself is not running. Now it will run, I guess. Yeah. Now it will run. Okay. That's fine. I'm not seeing the logical problem, but there is a logical failure. That's true. What else? It's not a prime number. Why is that? 23 is. Okay. Okay. So if it is perfectly divisible, we set it drag equals to 1, right? That's how we should do it. Yep. That's my logical failure over there. Okay. So it should have been like the even number is basically, or whatever. If there is no remainder, that means it's divisible, right? Hence, it's not a prime number. That's how I should have done it. Okay, what is this Chang Armstrong number? Right, 1 to the 3, this 3, this 3, okay. Oh, we will need to use some kind of mathematical operation over here, right? Okay, not required maybe. So original number is, in order to get the last digit, of course, we will need to divide it by 10, right? So it will be 150, so it will be 3. The remainder will be 3. Add the cube of the last digit to the sum. Remainder. I'm not sure about this operation. Huh? I'm not sure about that. And of course, the original number is basically, we will need to change it as well, right? So that's why we do divide by 10. So that will be 150. Next time it will be 15, right? So sum equals original number, but original number is already changed, right? Let's do number, right? So basically, in this case, what happens? It's an Armstrong number because this is 27, 125, right? And that. Yep. So this will be 125, 27 will give us 152, and 1 cube is 1, so 153, right? That's why. And I'm a little bit confused over here. So maybe let's just do simple mathematics. Huh? So I just don't want to do any fancy things. Right, and it should be plus equals to, I guess. Okay, so since that's a sum, and we will need the closing thing, semicolon. Yeah, it works. Oh my God. Okay, so what's happening in this loop? I'll just try to explain it in simple words. Okay, what happens is basically in the first iteration, the number is 153, right? I'll try to bring out my thing. I can't hide this thing. Huh? Okay, I will need something else to explain it. Okay, it's a little bit brighter. I can make it dark, not a big deal, right? So what happens over there is basically, okay, so we have a number 153, right? I will need to make this thing white, right? We have a number, given number is 153, right? So what's the number in the digits place, right? So if we were to, so divide by, okay, divide by 10, right? So it would be 150 and then 3, right? So this is like the remainder part of it. Okay, so let's just cut it, paste it somewhere here, right? So that's the number, right? So it's the main part and then the remainder part, right? So main part and then the 153, right? So if we were to do something like this divide by 10, what would we get? We would get this, right? But since we are telling it to get, it's not a double that we are defining, right? We are defining an int in this situation. Where is that? Okay, it's over here, right? In this situation, we are basically just dividing it, right? And original number is of what data type? It's of int data type. That's what's handling it. Okay, so as you can see, right? So if we were to do something like floor division, not sure if there is a function over here, floor math, right? And we do that, right? Divide by 10, I guess, right? So as you can see, it'll give us 15. Okay, so we are only doing getting the first component of it. Okay, so remember how you do mathematics. So 153, right? So how much 10, how much will be 153? So 15 will give us 150, right? And then when you subtract from this, right, so it will give us 3, right? So this is the component that we are looking for. Okay, so the division, right? So 15 is there, remainder is 3, right? So that's what we are doing. Okay, and in the next thing what happens is basically we are making this as a main number, right? So in the next thing what we are doing, we are making this as a main number. What's the main number now? It's going to be, let's just copy this, let's paste it here, will be 15, right? And what will be the floor division? I'll just copy this thing simply, right? Paste it here, right? It has to be some other kind of number, this number, right? It will be 1 in that situation, right? And the remainder will be 5, right? Why is that? Let's do a mathematics of it. 15 will be 1, right? and it will be 10. Of course, the remainder will be 5. Right. Then what will happen? The main number will be 1 now, right? When we copy this, paste it over here, right? It will be 1 divided by 10. So in that case, it will be 0, right? And what will be the remainder? It will be 1, right? So that's how we basically did this. Okay, so I could show it to you. It's not a big deal for me. Print f, right? Percentage t, original number, right? Let's just check the code, right? As you see, it's 15 and then it's 1 and then 0, like I actually told you, right? It will run for how many times? It will run for, of course, we will need to make it as a 0 as well, right? So then it becomes 0, right? At the how many times does the loop run? It will be 15 at the beginning, then it will be 1, right? That's the second iteration, then it will be 0. Okay, then it will be 0, and once that's done, it will basically not work after that, right? So that's how it basically works. Okay, so if you don't understand it, do look at this problem. It's an interesting one. Everything else is just basic math. The only thing that you need to remember, how does this loop it gets out of here, is basically we are changing the original value. First of all, it's 150, right? 150 divided by 10 will give us what, 15. And then in the next iteration, what happens? It'll be 1. In the next iteration, it'll be 0. Hence, when it goes back to the main over here, it's equals to 0, right? Hence, this condition is false. Then it moves downwards. Okay, that's what happens in this code. It basically loops 3 times based on the digits place. Okay, so that's how it works. We need to check if a character of alphabet, if it falls under the range of this or this. Okay, so if something, right? There is always if, else something. Right, if it is within that. We are getting character, right? So character, it can be interpreted as number as well, right? We know that. And so if it falls within this, we say we prints print f will be alphabet. Print f is alphabet, otherwise it's not an alphabet, right? Copy it, paste it there, otherwise it's not an alphabet. All right, okay, so we will need to find the value of a, right? So whatever the alphabet that we are assigning, of course we can simply do character is there, right? So I think character does it. So alphabet something like alphabet is greater than equals to something, right? Greater than equals to a, and if it falls under something like you know alphabet less than equals to z, something like this, of course there will be an error, but yeah. Okay, it's not an alphabet. Okay, z is not there. Okay, so maybe we can simply do that, or could do something like that. Just copy and paste the whole thing, copy, right, and then just or statement again, and then just a, and then this will be z, right? So c. Okay, everything is the alphabet now. That can't be true, so we will need to do and 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 then inside here what we can do is do and, right? We will need to check for both condition, right? So we could have done it in multiple else if kind of condition as well, but we chose to do it like this. Okay, so if it is right, so if it is z, so it will have to fall less than or thing, right? So it will have to be over here, so it will be what, true over here, false over here, right? So it will basically be false in that case, right? So false in that case, and somewhere over here it has to be like true kind of thing that satisfies, right? Okay, let's submit it. Okay, we need to find the greatest factor. Similar kind of problem, right? Int create a loop, I that is equals to number minus 1, right? That should run until I I is greater than or equals to 1, and then it should be I minus minus, right? We need to decrease I, and then the number is divisible by thing is equals to thing. Then what do? We just do printf. Printf, right? Percentage d, we first of all print and then only break out of the loop. Break, right? Not break and then print, right? It will never execute. Okay, so that's how we can do this problem. Not a big deal, right? We are just doing a reverse kind of thing. It never executes like that, right? The first condition itself is not being satisfied, that's why. Right, let's submit it. What is this? Employee bonus, right? So we are given this, blah, blah. So we need to check if the service year is greater than 5. Then we need to print the bonus and whatever, right? So this is greater than 5. We do and LF, all right? That will be what? Just the same thing, the same logic, right? Oopsie, oopsie. I don't need your explanation. I know it. Why is this thing not being copied? Okay, so let's just check it. What happened? Ah, percentage. Told you I'm bad at C. Great, works. Let's submit it. Let's do the other one in the next one. Right, because we've got to check a lot of things over here. All right, so it's just multiple condition kind of thing. Okay, let's do this in another session. Huh? Let's keep it until over here. Thank you for your time. Take care. Bye bye.